World models are action-conditioned latent dynamics models of an agent's environment. In this paper, we demonstrate the use of generative world models for end-to-end training of autonomous driving agents. We tested our trained policy in closed loop in the CARLA simulator as well as NVIDIA Drive Sim. Here we see our agent stopping for a stop sign in Drive Sim, then stopping for the turning vehicle, and finally turning right. On the top right, we see the navigation cue provided to the model. Our agent's behaviors are learned from data and not hand-coded. Here we see the model stopping for a red light. Covariate shift is a problem in imitation learning, especially in sequential decision-making tasks like self-driving, where the states experienced by the learner diverge from those in the demonstrations, leading to a compounding of errors. Closed-loop training with a generative world model increases robustness to covariate shift by allowing the learner to visit those states outside of the expert demonstrations. A typical behavior cloning architecture may look like this, where the inputs go through a perception encoder that generates a feature vector, which is then used by the policy to generate output actions. The model can be extended to accumulate temporal history by adding a recurrent model. Our end-to-end trainer aggregates states over time using a history model. We sample prior and posterior world states from the generative world model and the state estimator. KL divergence between the prior and posterior states pushes the agent back towards expert states whenever it drifts. We also decode the latent state into an RGB image through diffusion or a bird's-eye view semantic representation of the world. For the perception encoder, we architected a novel transformer-based encoder that allows to additively combine tokens from many input modalities. The following videos show our model driving in closed loop in the CARLA simulator, tested in towns that were not in the training set. The training data was collected in CARLA Sim using a privileged agent roach similar to the Mile paper. We see complex behavior where the agent stops for red lights, yields to pedestrians crossing the street, and stops for stop signs. Among comparable models in the CARLA Leaderboard 1.0, we achieve state-of-the-art driving, route completion, and infraction scores. We also compare our model against behavior cloning in the CARLA simulator. The significantly higher scores suggest that the world model trained policy is more robust to covariate shift. In this example, we see the BC agent on the left crashing, while the Gen world model agent on the right does not. We next purposefully push the models outside of their training distribution by applying lateral perturbations. The world model trained agent recovers from both perturbations well, while the BC policy crashes. Further closed-loop tests from NVIDIA Drive Sim show the model handling steep hills, stopping for stop signs, changing lanes to take over other vehicles on the highway, and driving even in the absence of navigation cues as indicated by the empty box on the top right corner. The model can stop for red lights and then resume and finally perform an unprotected right turn at a red light. These are all behaviors learned purely from the real-world training data without any hand-coded rules. Finally, we show results on the new planned dataset how the prior or the posterior latent states can be decoded into temporally consistent RGB and BEV images using latent diffusion models. We invite you to read our paper for more details. Thank you.